Hi everyone, this is Mrs. J, and today we're going to learn how to multiply and divide rational expressions. Alright, before we get started, I have a quick warm-up for you guys, so please pause the video and give these a try, and then hit play when you're ready to check. Alright, go ahead and check your work here. So remember, first thing we should do when we're adding or subtracting is we should still list the excluded values. For the first one, x cannot equal 0. And then we look at our LCD, which in this case is 6x squared. So on the left, we need to multiply by 3 over 3 to achieve 6x squared. And on the right, we need to multiply by 2x over 2x. And then once the denominators are the same, we simply add the numerators. So 15 plus 14x, or in standard form, would be 14x plus 15 over 6x squared. Then for part B, make sure you factor your denominator here first, using difference of two squares. And here you can see we have two excluded values, -2 and +2. Our LCD is going to be x plus 2 times x minus 2. So it includes all of the possible factors. So on the right side of our expression, we need to multiply by x minus 2 to achieve our LCD. And then again, once these are the same, we can simply subtract the numerators, which I did here. And then we do need to multiply these out. Be careful, when you multiply them out, they need to stay in parentheses because this negative does need to be distributed to each term. So you should end up with -x squared minus 3x, and then we have 3 plus 10, which is 13. All right, so today we're going to be multiplying and dividing rational expressions. So here's a quick review of the rules for multiplying and dividing fractions. So to multiply two fractions like a over b and c over d, we simply multiply across the numerator, so ac, and then we multiply across the denominator, bd. And then we'll have excluded values from both denominators, so b cannot equal 0 and d cannot equal 0. Now when we're dividing rational expressions, there's an extra step. So remember, when we're dividing with fractions, we actually multiply by the reciprocal of the second fraction. So you can see here, the a over b stays the same, and then the divide turns to multiplication, and then this is the reciprocal. So instead of c over d, it's d over c. And then we simply multiply across the numerator and across the denominator. Now here with the excluded values, we need to be careful because you need to look at the excluded values from your original problem. So b cannot equal 0 and d cannot equal 0. But then also from the reciprocal, as soon as you flip this fraction, there's an extra excluded value. So c also cannot equal 0. So we're going to be applying these same basic rules of fractions to our rational expressions. All right, so let's get started. We're going to find the product of these two rational expressions and list any excluded values. So for these problems, the first thing you're going to want to do, if it's not already done for you, is to factor everything that you can. So this we can factor with magic x. It's x minus 4 times x plus 2. And then here up top, we can start by factoring out a GCF of 2. So I'll kind of do this on the side. So it'd be 2 times x squared minus 3x minus 10. And then this, we can actually factor more using magic x. So the entire expression becomes 2 times x minus 5 times x plus 2. And then in the denominator, again here, we can factor this. This will become x minus 5 times x plus 2. All right, so before we start multiplying across or canceling out common factors, we do need to list out any excluded values. So again, we look in our denominator, and any factor in our denominator will give us an excluded value. So here, x minus 4, that factor tells us that x cannot equal +4, because that would turn this factor to 0, and you can never divide by 0. This factor tells us that x cannot equal -2, And this factor tells us that x cannot equal positive 5. Here we've already included negative 2. So we have 3 excluded values. So we need to list those out before we start canceling out common factors. So here you'll notice that on the right side we can actually cancel out 2 factors. So we'll do that. And now all we need to do is multiply. So we multiply across the top. 3 times 2 times x squared is 6x squared. And then what we have left in our denominator is x minus 4 times x plus 2. And this is our final simplified answer. All right, let's try another one together. So let's start by factoring. So here in our numerator, we have a GCF of x. So this becomes x times x minus 8. And then our denominator, we have 14 as a factor. And then this trinomial can be factored to x plus 5 times x plus 3. And then on the right side, there's a GCF of 7. So we have 7 times x plus 5 over x plus 8. All right, so now let's list any excluded values. So 14 doesn't give us any excluded values because there's no variable. So 14 will never be able to turn to 0, so we don't worry about it. This factor tells us that x cannot equal negative 5. Here we see that x cannot equal negative 3, and here negative 8. So it's always the opposite of the number we see in the factor. Okay, so now if we are multiplying, again, we kind of multiply across the top and across the bottom. So here we have 7 times x, so 7x times x minus 8 times x plus 5. And then in our denominator, we have 14 times x plus 5 times x plus 3 times x plus 8. And then we just look for common factors to simplify. So you'll see that we have a common factor of x plus 5, so that will cancel out. And then you'll also see that our numbers in front can be simplified. 7 and 14 are both divisible by 7. So this 7 turns into a 1, and this 14 turns into a 2. And since that's all of our common factors, whatever we have left will be our final answer. So in the numerator, we have x times x minus 8. And in our denominator, we have 2 times x plus 3 times x plus 8. And again, all of our excluded values are listed up here, which we should always do before we start canceling out any common factors. All right, so at this time, I'm going to ask you to pause the video and give this one a try on your own. And then when you're ready, you can hit play and we can check your work. All right, go ahead and check your work. So after we factor, we can find that our excluded values are positive 8, negative 3, 0. Don't forget that this factor of x gives us an excluded value of 0, and positive 9. And then once we multiply, we're multiplying across the numerator and denominator, we can cancel out common factors that we see on the top and bottom. So x minus 8 will cancel out, and x plus 3 will cancel out, leaving us with this as our final answer. All right, I have one more for you to try on your own here. So again, please pause the video and give it a try on your own. All right, so go ahead and check. Here I factor just the numerator, and from our denominators we can see that we have 2 excluded values. X cannot equal 9 or negative 1. Then you'll see we have a common factor of x minus 9, which will cancel out, leaving us with 3x over x plus 1. Now remember here, although I see an x in the top and the bottom, these cannot cancel out because we can only cancel out common factors, and x plus 1 is the entire factor. So here we can never just cancel out part of a factor. So if you're really tempted to do that, just be careful that you are only canceling out entire factors. All right, so now we're going to try dividing rational expressions. So here we're asked to find the quotient and any excluded values. So we're going to start in the same way. We're going to factor. So in our numerator here, we have x plus 7 times x plus 7 over x squared, and then that's divided by, here we can factor again, x plus 7 times x plus 2, and then here we have x plus 2 over x minus 1. So again, I'm not going to do the reciprocal yet. Here we're just factoring, so we can mainly look for excluded values. So look in your denominators. We can see that x cannot equal 0 from this factor, and then -2 or +1. However, we know that there's also going to be another excluded value when we actually multiply by the reciprocal. So now we'll rewrite our first expression. Remember, dividing rational expressions, we again multiply by the reciprocal of the second one. So notice I'm going to flip the numerator and the denominator of our second expression. And when we do that, it actually creates a fourth excluded value. We see that also x cannot equal -7. Here, -2 was already included. So this is our complete list of excluded values. So don't forget to list them before and after you multiply by the reciprocal. And now we can start looking for common factors in the numerator and denominator to simplify. So here we see a common factor of x plus 2, and we also see a common factor of x plus 7. So what that leaves us with is x plus 7 times x minus 1 over x squared. So just remember that when you're dividing with a fraction, you have to multiply by the reciprocal of the second fraction, and just be extra careful that you're listing any possible excluded zero. So anytime you have something in your denominator, check for a restriction. All right, let's try another one together. So let's start by factoring. So here we have 6x, then we have a GCF of 3 in our denominator, so 3 times x minus 10. And then divided by, okay, here, this may be a two-step factoring. So first thing to notice is that there's a GCF of 9. So let's factor that out first. That leaves us with x squared minus 3x minus 4. And then this can actually be factored more. So this results in 9 times x minus 4 times x plus 1. And then in our denominator, we have a GCF of x, so x times x minus 10. So now I'm going to take a moment and list any restrictions I currently see. So this 3 doesn't give us any restrictions because it will never turn to 0. This tells us that x cannot equal +10. And this tells us that x cannot equal 0. But remember, when we're dividing, we actually have to multiply by the reciprocal of the second fraction. So I'm going to flip the numerator and denominator here, and then we're going to check again for more excluded values. So after we flipped it, we see more things in our denominator. We see that x cannot equal +4, and we see that x cannot equal -1. So here's our complete list of excluded values. And now we're ready to essentially multiply across the numerator and denominator. And then we can also look for common factors. So we see x minus 10 is a common factor. And then you can see here, we can actually divide both of these numbers by 3. So this turns into a 1, and this will turn into a 2. And then what we have left is 2 times x, so 2x squared in our numerator. And in our denominator, we have 9 times x minus 4 times x plus 1. All right, so I have one for you to try on your own. So please pause the video and go through the entire problem and then hit play when you're ready to check. Okay, go ahead and check your work here. So again, first factor, but leave the divide sign so we can look for excluded values. So we can see that x cannot equal 0, -3, or +1. And then we do need to multiply by the reciprocal of the second expression. So when we flip it, we'll see that there are no new excluded values because we've already listed -3. And so now we're ready to multiply across the numerator and denominator and cancel out common factors. And that leaves us with x plus 1 times x minus 1 times 8x over 8x. All right, here's the last example from the video. So again, please pause the video and give it a try on your own, and we will check your answers in just a few seconds. All right, go ahead and check. So you can see here, I factored everything that I could, and this gives us some restrictions. So x cannot equal 0, +7, or +8. And then in this next step, I showed that we're multiplying by the reciprocal. So check again for more restrictions, but we've already listed 0 and +8, so there's no new excluded values. And now we can look for common factors. So the x minus 7s cancel out, x minus 8 cancels out, and then 20 and 5 are both divisible by 5. So you can see this becomes 1 and this becomes 4. So all we have left in the numerator is 4, and then all we have left in the denominator is x squared. I do want to point out, if every single factor in your numerator cancels out, it doesn't disappear, it doesn't become 0, it does become 1. All right, that's all for today's video. Thank you for watching.